Hi there and welcome to Penguin Learning. In today's National 5 and GCSE Maths lesson, we are going to look at the cosine rule. First of all, we are going to go over a quick recap on the sine rule and how it's similar to today's lesson, but then we will go on to introduce the main topic, which is the cosine rule. After this lesson, you will know what the cosine rule is and how to use it to solve problems. We will then go over a few examples just so that we can practice our problem solving skills related to the cosine rule, and finally we are going to end by looking at the differences between both the sine rule and the cosine rule and how we can use both of them to solve problems related to triangles. So let's get started.
Ooh la la!
Okay, so in the lesson we had on the sine rule, we said that we could label any triangle in the following manner. We said that each of the three corners that make up the triangle could be labelled capital A, capital B, capital C, and these values represented the angles within these corners. And then what we can do from there is then label each of the sides according to which angle it lies opposite. So for example, here we have angle A, and opposite that is side A, and that's represented just by the smaller case a, and that's the same here with smaller case b lying opposite angle B and smaller case c lying opposite angle C. And in the previous lesson we said that we can use the sine rule in order to relate the three corners or the three angles to each of the three sides that make up any triangle, and the sine rule was length A over the sine of A is equal to length B divided by the sine of B, which is also equal to length C divided by the sine of C. And if you haven't yet watched our lesson on the sine rule, I'll make sure and link it down below so you can watch it after this lesson. But in this lesson, our focus is going to be on using and explaining the cosine rule. Now the sine rule and the cosine rule are similar in the fact that they both relate the three angles to the three sides that make up any triangle, but their application in terms of how and when we can use them are slightly different. Now at a first glance, the cosine rule which we have here might seem a little complex at first, but once we get used to it, it's actually not that bad. So the rule states that a squared, so this side here, is equal to b squared plus c squared. Then we minus this full thing here at the end, so it's minus 2bc, and then the cos of angle A. Now when we group a term like this together, what that means is 2 times b times c times by the cosine of A. This is what this last part of the cosine rule represents. So if we don't have any sign in between the terms here, then all it means is that they're all multiplied together in this fashion. Now I'm just going to analyse the cosine rule a little bit and just see what terms we actually have in the equation, okay? So first of all, on the left side we have A, which is one of the lengths, and then on the right side we have length B and length C. So we've covered these parts here. Then in this last term in the equation we also have B again, we have C again, and then it's the cos of angle A. So the only other term that we have in the cosine rule is angle A. So we have sides A, B and C and some angle as well. So that means that if we have the cosine rule in this form and we want to calculate what the length of side A is going to be, then what we need in order to use the cosine rule is the length of the two other sides, so B and C, and then also what we need is the value of angle A as well. So what that means is, if we want to find the length of any side in the triangle, we can use the cosine rule if we have the length of the two other sides. So let's say for example we want to figure out the length of side A if we have both B and C and the angle between the known sides, which is also called the included angle. So if we know B and C, the included angle is going to be angle A. Okay, to show how we can use the cosine rule, I'm going to start by doing an example. So here we have a triangle and we want to calculate the length of side X, and we know that this length here is 86, this is 65 centimetres, and we have an angle here of 19 degrees. So the first thing to do in beginning a problem related to the sine or the cosine rule, what we have to do is label the triangle. So I'm going to label this angle A, this angle B, and this angle C, and then for the sides, well, the side opposite A is this one, the side opposite angle B is this one, and the side opposite angle C is this one. And one thing that I want to point out is that notice the side that we want to calculate the length of, so side x, I've made this side A, and making the side that we want to calculate side A makes our life a lot easier because the way the cosine rule is set out is that we already have A pretty much by itself on the left hand side. The only thing is it's A squared, but that just means that if we want to get A, all we have to do is take the square root of this value. So having the unknown as A makes the equation a lot easier because on the right hand side is everything that we will know, and on the left hand side is what we want to figure out. So from the diagram we can see that B is equal to 86 centimeters, side C is equal to 65, and then the angle of A is equal to 19 degrees. So putting these values into our equation for the cosine rule, we can see that A squared is equal to 86 squared plus 65 squared, which is C squared, and then minus 2bc cos A, that's going to be minus 2 times 86 times by 65, and then finally multiplied by the cos of 19 degrees. Now what we have to do is solve the right hand side, and we have to do this using a calculator. Now what you can do is either put all this full expression into the calculator as it is, or you can do it bit by bit, which is what I'm going to do. So for example, I'm going to first calculate 86 squared, and then 65 squared, and then this term at the end. So 2 times 86 times 65 times by the cos of 19 degrees. So 86 squared gives us an answer of 7396. 65 squared gives us an answer of 4225. And the last term gives us an answer approximating minus 10571. And then if we collect all the terms on the right hand side, we should get an answer of 1050, and that means if that's equal to A squared, to calculate A, what we then have to do is take the square root of this value, and if we put this into our calculator, what we should get is an answer roughly equal to 32.4 centimetres, and this answer is to 1 decimal place. So just a quick recap on that question, the first thing that we had to do is label the 3 corners and then the 3 sides, and I did so in a way to make sure that the unknown side was equal to A, and that means that we didn't really have to rearrange the equation at all. All we could get is an answer for A squared once we put in the values for everything on the right hand side, and then once we had that, all we had to do is take the square root, and that gave us our answer for the length of side A. So that example we just went over there showed us how we can use the cosine rule in order to calculate the length of a side. But now I'm going to show you how we can also use the cosine rule to calculate the value of an angle. So we said that the 4 variables that make up the cosine rule are the length of the sides, A, B and C, and one angle that we have which is capital A. And to calculate the value of any one of these, what we must have is the value of 3 other ones. So for example, what we just calculated there was the length of side A, and to do that what we must have is the length of the 2 other sides, so B and C, and also the included angle A. But let's say now we want to calculate the value of an angle within a triangle. Then to do that using the cosine rule, what we must then have is the length of each 3 of the sides that make up the triangle. So side A, side B and side C must all be known. And then if we look at the equation here, if we have values for A, B and C, that means that we could rearrange this by somehow using algebra and changing the subject to get an answer equal to A. So let's do an example related to that now, how we calculate an angle using the cosine rule. So let's say here we have a triangle of sides equal to 5 centimeters, 4 centimeters and 7 centimeters, and what we want to do is calculate the value of this angle here by using the cosine rule. Now we can see that in our equation what the value for the angle is capital A. So what I'm going to do, just so we can keep this same form of the cosine rule, is make sure that this angle here is angle A. So I'm going to label this A, and then the 2 other sides B and C. It doesn't really matter what they are. And then from that means that this here would be side A, this would be side B, and this would be side C. Okay, so the next thing that we have to do is rearrange the cosine rule so that we have the angle A the subject of the formula. Now you might already be given this equation, but I'm going to go through it step by step just so you can see how we can get from the original cosine rule to the one where we have the angle as the subject of the formula. So to begin, I'm just going to flip the right side and the left side so that we have the angle, so cos A, on the left hand side. So that means we can write b squared plus c squared minus 2 bc multiplied by the cos of A, and that is all equal to a squared. So because we want cos A the subject of the equation, what I'm going to do is leave this term as it is just now because it contains the cosine of A, and because they're all multiplied together, what we can do first of all to take stuff over to the other side is deal with this b squared and this c squared, and because they're positive on this side, on the left hand side, we can take them over to the other side and they become minus or take away. And taking them over to the other side, we would then have minus 2bc cos A, so just this term here, is equal to a squared, and then we take the minus term, so minus b squared and minus c squared. But one thing I don't like at the moment is this negative sign, so what I'm going to do now is try and get rid of that. In order to do that, what I have to do is take a common factor of minus 1, or just a minus sign, on the right hand side, and that means that I would cancel out with the 1 on the left hand side. So if I want to take a minus sign out as a common factor, that means that every term on the right hand side is going to be flipped in terms of its sign. So what's minus becomes positive, and what's positive becomes negative. So we're going to have b squared plus c squared minus a squared. And that means now the two minus signs on either side cancel out. So we're left with 2bc cos A is equal to b squared plus c squared minus a squared. Now what we want to do is get rid of this 2bc we have on the left hand side, and we know that on the left hand side here all these terms are being multiplied together, so that means that this 2bc is 2 times b times c times by the cos of A. Now if we wanted to get rid of that, what we could do is take it over to the other side, and because this is being multiplied on this side, when we take it over it's going to be divided by on the right hand side. So that means our equation becomes the cos of A is equal to b squared plus c squared minus a squared, and then that's all divided by what we just took over, so the 2bc. And now here we're just left with an expression on the right hand side where we have A, B and C, so the three sides that make up the triangle. Now what I'm going to do is just put the values for each three of these sides into the equation. So that means we're left with the cosine of A is equal to 4 squared plus 5 squared minus 7 squared, all divided by 2 times 4 times 5. And if we calculate all of this, we should get an answer equal to minus 0.2. So we're left with the cosine of A is equal to minus 0.2. But remember, what we want to calculate is the value of angle A. So that means we want A by itself in this equation, and not just the cosine of A, so we have to get rid of the cos A somehow as well. And to do that, what we have to do is take this cos over to the other side, and doing that means that we have to take the inverse function of cos. So that means that we can write angle A is equal to the inverse cos function of minus 0.2. And then finally, if we put this into our calculators, what we should get is an angle A equal to 101.5 degrees. So this question showed how we can use the cosine rule to calculate the angle within a triangle if we know the length of the three other sides. And the original cosine rule was a little bit tricky to do this, so what we had to do was rearrange this equation in order to make the angle the subject of the equation, which we got to here. We then plugged in the values on the right hand side. We took the inverse cos function to get A by itself, and that left us with our final answer. Okay, so just to finish up this video, we're going to compare both the sine rule and the cosine rule, and how we can use each of them in order to solve problems related to any triangle. So the first and most obvious way of distinguishing the sine rule from the cosine rule is that the sine rule contains the sine function, and the cosine rule obviously contains the cosine or cos function. So looking at the sine rule first, let's say for example we want to calculate the length of side A. Using the sine rule, what we would then need in return is the length of one other side, so either B or C. I'm just going to select B as an example. And what we also must know are two angles within the triangle as well, And if we have the two angles, that means we can also calculate the third if necessary, because we know that all three angles in a triangle add up to give 180 degrees. So that was the first way that we can use the sine rule to calculate the length of a side. But we can also use it to calculate an angle within a triangle if we know, first of all, the length of side A and any other side as well. So I'm just going to select side B, and whatever other side that we chosen, so side B, we must also know that angle, so angle B, and then that would allow us to calculate for the sine of A, and that will give us angle A. And then moving on to look at the cosine rule, the first way that we can use it is by calculating what the length of a side will be, so in the form of A squared is equal to B squared plus C squared minus 2BC cos A. And it's easy just to say that if the side that we want to calculate is A, then our equation is pretty much ready and it's the subject of the equation. And to calculate the length of side A, what we then need are the length of two other sides, so B and C must be known, and then what also must be known is the included angle, or the angle between the two known sides, and in this case it's angle A. So if we know the length of the two other sides and the included angle, then we can use the cosine rule to calculate the length of A. And then the last form that we can use the cosine rule is for when we want to calculate an angle. And then the equation becomes cos of A is equal to B squared plus C squared minus A squared, all divided by 2BC. And in order to do this, what we must know are the length of all three sides in the triangle, so A, B and C. If we know the length of each three of these sides, then that will allow us to calculate angle A or any other angle that we want to. So I hope this has been a helpful lesson to you in understanding what the cosine rule is and how to use it. And if that's been the case, please give the video a thumbs up. We greatly appreciate it here at the channel. And if you'd like to see more content like this, be sure and subscribe and hit the notification bell. And if you have any questions on today's lesson, just drop a comment down below and I'll get back to you as soon as possible. As always, thanks very much for watching and I'll see you in the next video.